Greetings, everyone. Greg Stewart here with Maizex Seeds. Welcome to you and everyone joining us across Canada for this Decipher Debate and Decide series. This is our final session in this series. Today we're talking about corn silage, specifically sampling the field and the bunk and discussing important benchmarks for corn silage. Our guest presenter today is Dan Goodson from Wallenstein Feed and Supply. Dan is an on-farm feed advisor. He joined Wallenstein in 2016. Prior to this, he managed dairy herds in England, his native land, New Zealand, and of course here in Canada. Dan spoke to us at our silage meeting a year ago in Listowel. It seems like about 100 years ago, to be honest with you, but we're delighted to have him back to lead this discussion today. Joining us for today's discussion is our color commentator, Adam Parker. Adam is a territory manager with Maizex, covering a large area north and west of Guelph. Adam also farms with his family near Guelph and has a real keen interest in getting the very best connections between agronomy, corn hybrids, silage, and animal performance. The first 45 minutes of our session will focus on laying out the information, and this will be followed by a question and answer period. So insert your questions into the webinar question box that you see on the screen. With that, let's turn it over to Dan.
Thank you, Greg. Thank you, and I appreciate the invitation to speak to you guys here today. As Greg mentioned, I'm a feed advisor with Wallenstein Feed, and the other person in the picture here is Holly McGill, and she will be joining us for the questions and answers. A bit about Wallenstein. It's a feed company based in southwestern Ontario, and we specialize in feeding solutions across poultry, swine, and of course, ruminant and dairy. Our ruminant team is focused on all aspects of dairy farming, nutrition obviously being first and foremost, but we do stretch further into other aspects of the business, including management and economics. We pride ourselves in putting producers first, and your success is what drives us. We have 6 nutritionists typically on site, although with COVID and everything, we haven't quite been on site as much as we'd like to be, and 8 reps on the road. And we do cover all of Ontario. So if you're looking for a second opinion and perhaps advice on a new feeding program, there'll be someone around to assist you. So don't hesitate to get in touch. That's the plugs, and we'll get along with the presentation. So as Greg mentioned, it's sampling the field and the bunk, important benchmarks from corn silage. So the goal here today is to discuss the corn silage and what our goals are. Long and the short of it is, when you look at a feed analysis like this, it can be quite intimidating with all these numbers and letters. I think there are 50 odd values here to try and evaluate, what are we looking for? And what I'm going to try and do is break that down into some key elements and bite-sized pieces. And some of those are what's circled here. Again, make it a little bit more digestible, a little bit more palatable, and focus on some of these key values. This same sample here, this is to demonstrate the fact that no corn silage is like another and how much one can vary. Down the middle here are the average values relative to the nutrient. And this is the same sample with the black marks representing where it is on that sliding scale. You don't need to pay attention to the numbers here, but this is just a demonstration of how these numbers can vary. And with this starch percentage, for example, here at 41, this is at the higher end, but it will perform very dramatically to a corn silage, down below 30 at 27. So no corn silage and no analysis is completely unique, is like another one. They are completely unique. And also worth bearing in mind, when you look at something like this, just because a number is higher doesn't mean that it's better. On to the next slide. So this slide, this is basically a spoiler alert. This is exactly what we're going to be working towards, these key corn silage benchmarks. If there's one thing to take away from today, this presentation, it is this screenshot, these key factors in these key areas. This is what determines key corn silage benchmarks. There's a reason why this presentation isn't, 40 seconds long, and I need to explain these benchmarks, their purpose within the ration, and also some of their conflicting elements within corn silage. And be aware that one perfect value and factor does lead to sacrifice of another. For example, yes, we want our starch to be as high as possible, but is that going to be a cost to sort of fiber levels and digestibility? It's also worth remembering that not one of these values truly defines a corn silage's quality, no individual. And the bad news is that it is extremely hard to achieve absolute optimization in all of these different aspects. But hopefully we can get somewhere close by following a few guidelines to not only aid us in maximizing a crop's potential, but in also avoiding pitfalls to not get the most out of our crop. The goal is going to be that you're going to have to talk with your agronomist, your nutritionist, and focus on harvest time so that we can strive to improve these qualities right across the board, get that optimum level. There is going to be a fair bit of repetition here, and we will see this slide again at the end as a reminder, and I think Adam and I will discuss it a little more in depth. But I think it's worth bringing these up as key factors so that we know what we're going to be talking about and get us thinking about these values as an entirety. So what I'm going to do, I'm going to work things a little bit backwards. I'm going to start off with the final ration so that we get a good understanding of what corn silage does to the cows and does in the ration, and then move backwards through the elements and then talk about at harvest our decision makings when sampling in the field and why we do those to, again, we have the reasons of why we're making these recommendations. So first and foremost, when thinking about corn silage, we have to remember, why do we feed it? Well, the reason we feed corn silage is it provides more digestible energy per acre than any other forage. It offers this also twice the yield of any other perennial forage, but in only one cut. So less labor, less time, less inputs, and you're getting all this in one cut. You have to think of corn silage like a forage in a sense, because it's 50% forage, it's 50% grain. Think of corn silage ultimately as a grass with a cob. It's a poor grass with a cob, and can be treated as such. And nutritionally, we do actually look at it that way. We do divide things up into, fibers and starches, but we don't harvest and we don't feed in that way. It is one single ingredient with those two big factors. So move on. Again, remember that the reasons why corn silage is in these rations. So corn silage in the ration. Corn silage, we have it because we want that energy, we want that digestible fiber to feed the cows. The rumen bugs and the rumen microbes use carbohydrates and cellulose to live and ferment and ultimately produce milk. Typically in Ontario, a high producing herd will have 1/3 to 2/3 of the ration will be corn silage. This is limited mainly because of corn silage is lacking in protein. Corn silage is somewhere between 7.5% to 8.5% protein. So we do have to make up this protein in the ration. Cows need 16%. So we do need to make up some more protein with other forages, and that's obviously typically your haylage. Again, the useful part of corn silage is the energy in the fiber. Feeding those rumen bugs that feed the cow that feeds the milk. So we will move on to a typical ration. And this is probably might be a little small to read, but I've just pulled up what I call a complete feed ration, meaning we have haylage, corn silage, they have a little hay on the side, some yeast, but a complete feed ration, which is the supplement and the corn all rolled into one. This ration the corn silage is 1/3 of the ration. Now, this is nutrition 101, but as fed, the haylage and the corn silage look very similar. But actually, on a dry matter basis, we're looking at 25% of the ration is haylage and over 33 is corn silage. So it's a huge part of it on a dry matter basis. As an ad fed, you might get, under the impression where it's a 50-50 split. And often I talk with producers about keep the corn silage haylage at 50-50 for, inventory purposes. Well, in reality, we're at a 1/3 of the total ration and actually 2/3 of the forage intake. So how does that reference to the ration? Well, corn silage in this case, same ration, is supplying 1/3 of the total energy in the ration. The corn silage is orange on this bar, so it's 33% of the total energy. The majority of the rest of the energy is coming from that complete feed, which in this case, a lot of it is dry corn. So again, thinking back to the corn silage in its entire, like as a singular ingredient, we need to maximize the energy that we can get from that corn silage, from that homegrown feed, rather than buying in a purchased feed from the big bad feed company. Regardless of the quality of the corn silage, the cows still have this baseline energy that they need to produce milk, to grow, to function, to reproduce, and we need to provide that. The more of that we can get from our homegrown forages, which is our cheapest feed in the ration, then the more cost effective that ration is. And in a lot of cases, the more high producing that ration will be. Ultimately, cows are grazers, and they do want to graze on that forage. And if we have the starch particles and energy particles in there, they will be more efficient with that. The other factor, as we mentioned, is the fiber in corn silage, and it's a big part. We do need fiber, but fiber is a limiting part of the ration and of corn silage. Again, much like energy, it supplies the majority of the total NDF, which is a portion of the fiber, the important portion that I want to focus on today. 36% of that total NDF is coming from corn silage. So the more available to a cow that NDF is, the more digestible, and perhaps the less fiber in that ration, the more forage intake we can get, and thus bring in more starch and energy from that corn silage. Obviously, the haylage, the dark green, is bringing in very similar amounts, but again, corn silage worth taking into consideration the contribution to the ration.
So Dan, just to explain NDF, I'm sure you'll get into these terms a bit more specifically, but NDF, yes. Simplified way to explain NDF.
Well, I will get onto that shortly, but the NDF basically is the digestible fiber portion of, is the digestible element of fiber. So the cows can process and break down the NDF. ADF is another portion of it, which is less digestible and almost the woody factor, the lignin and whatnot of the corn silage. So I will get into that a little bit more, but NDF and NDF digestibility, I mean, a lot of what we're going to talk about today is going to be based on sort of getting those levels to optimized levels. So now I'm going to move on to those elements. Corn silage, again, what I think, we saw the analysis earlier, what I think is the key parts of corn silage in terms of monitoring quality and the benchmarks we should be following are going to be your starch levels, your fiber levels, the digestibility of both the starch and the fiber, and then what we can control are processing and particle size. So let's move on to starch. I'm pretty sure everybody listening right now knows what the starch is. I mean, it's the grain portion of the plant, the kernel. It's high energy, and it is a significant contributing factor to the total energy consumed by a dairy cow. It directly affects milk production, and we can use it to optimize rumen fermentation. And as an added bonus, when the rumen bugs break down the starch and they've done their job, they actually turn to protein themselves. So that's another bit of a bonus. Requirements in the ration. So we need 24 to 28% in the final ration of crude starch. Benchmarking levels for a corn silage standalone on its own, a high level would be 45%, a low level would be 27. Average starch on the 2020 harvest was 38.6. Now, starch isn't you can't just look at the starch levels themselves. This is a great indicator, but we have, well, sorry, I should first touch upon this. As I mentioned before, the starch supplies, the corn silage is supplying more than half of the total starch in the ration, 56%. Again, the other 41 is coming from that complete feed. That's that dry corn that's purchased, that's bought from Wallenstein. The more of that we have, the less you have to buy in. Economics, you know, you're feeding your corn silage to your cheapest feed. The more efficiency we can get out of that feed, the better. The level of starch isn't everything, though. We have to talk about digestibility. Digestibility is how much of this nutrient is actually available to the cow and used by the cow. When we measure analysis, we do this and it's taken into account how the rumen works specifically when we balance the rations. This is a great way in determining the quality of the forage. One thing, and I'll mention this again, but fiber digestibility is determined as the corn silage come off the field, but starch digestibility, as I get into, will change and improve over storage. So starch digestibility, we use this, we use starch digestibility over 7 hours as our measurement to determine our benchmarks and our levels here. And this will be on your feed analysis. What that basically means is that 7 hours in the rumen, what percentage of the starch is available to the cow? Like, what can she use? Benchmarking, you really want to be using 70% and higher as your target levels for a higher quality. Now, one thing to note though, and this is very key when you're comparing corn silage, we were talking to Adam or Greg about you know, starch digestibilities, is when you sample that when you're looking at that analysis. This is one particular sample, September the 30th, right when it was harvested, you're looking at 56.6% starch levels, starch digestibility levels. That's percentage of starch. October 31st, a month later, 68, so almost 70. By January the 5th, we've actually turned what, you know, a low starch digestibility level, it's the same crop, same everything, to 80%. So this is one reason, why we look at, you know, you have to keep continuing sampling as a nutritionist, particularly over those first 3 months. And also perhaps think about, and this next slide will demonstrate this, think about having enough corn silage and having enough inventory to get you through so you're not opening that bunk up right away. This is the average average samples of corn silage from Cumberland Valley again, over the last year, this one, and how they changed through weeks in storage, weeks in the bunk. And you can see at 18 weeks post-harvest, that's when we peak out and sort of it then becomes stable. Of starch digestibility over time. So again, you are literally over the 7 hour period, you're getting another 15% out of that starch. So in effect, you know, you're able to feed less purchased grains or less or corn from your bunk, that corn silage is extremely more superior, 18 weeks post-harvest.
So let me just jump in there. That's intriguing. So two silage hybrids in a field that both had, I don't know, let's say they both had 38% starch.
Yes.
Is there a chance that their actual starch digestibility, when you measured them, 18 weeks later, that the digestibilities of those two silages, two hybrids, might be distinctly different, or do they all move roughly equally once you ferment them?
There will be differences. Certainly, there can be a big, large difference between the dry matter you got them off, how you stored them, if they're in exactly the same situation. But no, certain hybrids will perform better with better starch digestibility for sure.
So Adam, what have you seen on that front in terms of different products, in terms of where their digestibilities move? Do we track that?
Yeah, I think one of the bigger issues is the maturity and whether they were comparable in maturity at harvest. Just as that kernel develops and gets more hard, the drier that corn silage gets is probably the biggest fraction. There are obvious hybrid to hybrid differences. I think they're more minute than it would be than what we've seen at actual harvest maturity and harvest moistures.
Right.
Yep.
Thanks.
Yeah, and we'll get onto that in terms of optimizing this number for picking your dry matter at harvest time, and looking a little bit at kernel milk line. But it is important to, when you are evaluating things, if you're looking at a sample from 3 weeks post-harvest and you're comparing it with somebody else's plot or a trial that's 15 weeks post-harvest, they are going to be different. You are going to get dramatically different results. Another aspect that we really need to look at, and this is something that doesn't come up on analysis, you have to think about how labs work when they analyze. They grind everything down to a fine powder. So your starch digestibility, whether it's a full kernel or a tiny little particle, will test the same. And so how farmers can make the rumen and the cow actually be more efficient on a farm level is getting this processing and getting these kernels ground up to a suitable level. This again, you can literally improve and worsen corn silage, how it performs dramatically by your level of processing, and it worsens the digestibility regardless of the hybrid that you get. Just remember that corn kernels are a seed that are designed not to get broken down by an animal. That shell is designed to protect them as they get eaten, and then it comes out the back end of the cow, and then it will germinate and make a new plant. That's like this, the corn silage isn't trying to feed dairy cows, so you kind of have to remember that. By processing it, you're giving it more surface area within the rumen, and your smaller particles, allowing for this greater digestion and availability of the cow. So how we do this is we run it through a shaker box, through a 4.75 millimeter screen. You don't really need to pay attention too much to these numbers, but understand that you don't want to see any full kernels. It's just not acceptable. And this is something that really keep monitoring during harvest. You've got one shot at this. It's not a question of, don't be the person that's like, well, I have a good harvest guy and he's always done it and you need to, keep monitoring that and making sure you're not seeing any full kernels whatsoever. And again, the gold standard, and your nutritionist and maybe your agronomist, I'm not sure, can do this, where we sort of look at putting it through one of those screens and seeing, does 70% of those starch particles pass through once you've dried it out and shaken it through the shaker box? Does that pass through that that screen? So you really want 70%, but the easy thing to remember here is absolutely no full kernels. Adam, you might know better than this, but I think like setting your rollers at sort of 3 millimeters would be what I would recommend in terms of allowing that to happen.
It's easy during harvest to neglect this because the tighter the rollers are, the more horsepower it takes, or the slower it takes, the more time it takes the custom harvester to chop.
Yeah.
Everybody seems to be in a hurry that time of year, and I understand that, but it's when you look at the back end of the cow, or you pull a handful out of the bunk, and you start seeing those large fragments or even whole kernels. It's pretty disappointing to know that a bit more attention to detail in September, October has the ability to impact significant on that how the cow can utilize that silage.
Yes, and again, this is another reason why people like myself, we need to have eyes on this silage itself, and you need to see how these kernels and the fiber, which I'll get onto later, is processed and how these cows can access it, because the analysis does not tell us this. You know, if a corn silage isn't quite performing how it should be, you know, chances are we can point to something like this. Why isn't the analysis and the ration lining up with milk production? And it's about finding what these little things are. And go back to your point at harvest. I mean, I talked about it last year at length, but the economics of spending a little bit more time and running a little bit slower at harvest versus what it ends up costing you throughout the year. This is your crop for, you know, at least a year, hopefully. The economics of that, it only needs to translate into a couple of cents per cow per day, and that's it. That starts adding up, right? Like you really don't have to get too much of an improvement to make it worthwhile for a couple of $100 or an extra hour or so doing that, you know, making sure you've got the processing right. Now, convincing your custom harvester to do that might be a little bit tougher, but. So,
and Dan, another point on that is, you know, especially looking at dual purpose or grain corn hybrids that you're using for silage, and you're putting them in a tower silo at a drier moisture, that kernel processing becomes even more, so much more important, because that kernel is getting harder by the day.
Yes, absolutely. So, as I discussed earlier, like the corn grain part of it and the starch isn't all of it. The other 50% basically is the plant and the fiber. So a brief overview of what that is it's the structural carbohydrates that make up the rest of the corn plant, the grass, in the analogy of it being a poor grass with a cob. This is that NDF. So this is the cellulose, hemulose, and lignin. NDF is the digestible part of the fiber, and this can provide significant energy to the cow. The ADF, which I'm not really going to talk about too much, but that's the least digestible part of the component of the plant. This is basically your cellulose and your lignin. You want to keep that as low as you can. The cows need fiber. You know, they are grazers, and again, they do pull significant amount of energy and carbohydrates from these fiber, and fiber does help maintain rumen function and general cow health. I said it before, but cows are natural grazers. Here are the requirements. So we balance the rations, you know, to optimize the amount of fiber to maximize this energy intake. You know, if we have too much fiber in the ration, then intake is limited. If there's too little fiber in the ration, then this would obviously mean grains are higher. And now we're looking at problems with acidosis and even too fast a passage rate. You know, that's when you get loose cows and whatnot. So the requirements in the ration, giving 28 to 35% dry matter, ADF 18 to 22. So looking at the benchmarking when you're looking at your own samples of corn silage, average of 36 dry matter, low would be 31, high would be 40. So for NDF, we are looking, you know, the takeaway is that a low NDF content can be included at the ration at higher levels than with a high NDF. So consequently, we can pull more starch and more goodies along with a lower NDF ration. And again, to drive it home in for that high forage diets means healthier cows and a cheaper ration for the producer. Here is that slide that I showed earlier about the total NDF in the ration. We sort of went over this in brief, but again, we're looking at almost 37% of the ration is that NDF. So we're, again, pulling a lot through of that fiber through corn silage. Again, if we can limit that and get that as efficiently as possible, we'll be able to pull more, they'll be able to eat more and perform better. So much like starch, we have to talk about the fiber digestibility. This really is the kicker for me. Like, fiber digestibility is one of the key things when, evaluating a corn silage. This determines how much of that nutrient and how much of the whole plant. Like, it's the limiting factor. Like, starch digestibility doesn't affect, the whole plant, but NDF really does. Fiber digestibility has a large impact on milk production, and it really has to be high on the list of producers. The greater fiber digestibility is associated with a cycle that begins with greater rumen passage rate and ends with higher milk production. I haven't got it on this slide, but research shows that similar rations, you can expect to gain, if you gain 1% of fiber digestibility, this gives you an increase of 1/3 of a pound of intakes and then 1/2 pound of energy corrected milk, so at 4% butterfat, which again is not significant over a longer period of time. Again, worth remembering that fiber digestibility is determined when you harvest it, unlike starch, which does change and improve during storage. The NDFD is fiber digestibility, and the uNDF is undigested NDF. I'm going to get onto that here. So these are the two values that I look at when evaluating a corn silage. And honestly, I think that this is where we get a little bit of, can cause quite a bit of confusion, because we're looking at N's and D's and F's and U's and fibers, and, and one's got to be higher and one's got to be lower. So NDFD is the NDF digestibility, and typically we see a number after it. That number after it is done by the lab, and in general, it's 30, 120, 240, and that's hours of it theoretically being in the rumen. For simplification, as a producer, I would just look at the 30 number. So this for NDFD, NDF digestibility, 30 hours in the rumen. This is a process, so we're looking at 56% digestibility. You have to think of that like an action. So you actually want that to be higher. Again, it's a little bit of a hard concept to get your head around. So that is why uNDF, which is fairly new, is the area that, again, as a producer, if you just want to simplify things, look at uNDF, which is undigested NDF. And this uNDF is the undigested NDF, so the undigested portion of the fiber that comes out of the, or that is remained after 30 hours, or in other words, comes out the back end of a cow. This uNDF is also useful as it's, that's the limiting factor on intakes. And if you think that a cow can eat, around 3 kilos a day of uNDF, if you think of a cow's digestive tract like a flowing pipe or a pipe from start to finish, there's only so much that you can put in and get out. It's a constant moving thing. Well, 3 kg is always coming out the back end. Well, if we can limit the amount of that is 3 kg and they digest more of it, get it down to 2 kg, well, now, we're looking at 1/3 more we could potentially feed to the cow. And again, intakes and equals milk. Does that make sense? I know this is quite a, yeah.
So why is one number better than the other? In my simple way of looking at this, if it's digestible, NDF or undigestible NDF, are they not telling you the same thing, or are they telling you something different?
They're more or less telling you the same thing. But again, that digestibility is the rate, and it's the same. It's a similar thing to answer. Well, why do we have 120 and 240 as to do those rates when you look at a feed analysis? It's telling you the rate in which that is working in the rumen. It's a process, whereas the uNDF is a final figure.
Oh, I got you. Yeah.
Think of it almost like the speed you're going versus how long it took you to get there. Like
right.
I don't even know if that's a good analogy, but one is a process, and one is a fact. So
are they the inverse? Will they always correlate?
Yes, they will correlate. Yes, but like I said, if you for simplification as a producer, I think that just focusing on that uNDF rather than having so many more numbers in your head, that would help. But having a glance at the NDFD, the digestibility certainly doesn't hurt.
So the arrow on the left, looking at feed tests, would be the NDF divided by NDF 30 hour. That would be the line you're looking at there.
Yes. Yeah. So this is sorry, I didn't mention that. These are all percentages of NDF. This isn't percentage of the plant as a whole. This is measured on a percentage of NDF. So, and you can see why this complicates things, because it's not easy to talk about these three letters over and over again. So.
And your comment, Dan, was that unlike the starch digestibilities, these do not move
not significantly
during fermentation?
No. Not significantly, no. You won't get too much of a change, whereas starch digestibility is quite dramatic. So much like with the starch digestibility, processing also has a huge effect on the physical digestibility within the rumen and how it acts. Again, we're looking at creating this large surface area for the nutrients to be attacked by the rumen microbes in the digestive system, thus making it more efficient. We still want that effective fiber in there, so it doesn't mean, these fine particles in the bottom, it doesn't mean we want it ground to a pulp. We still need that matting effect, stimulate the chewing, but at the same time, we don't want everything to be, long, fibrous parts. Like, think of the extreme, I guess. You wouldn't just throw 4 corn stalks in front of a cow and say, go to town. There's only so much of that she's going to eat. We've got to help her along the way, but at the same time, like a soup isn't going to work either. So in order to measure this, what we do is the Penn State shaker box, which is what you see here, which has 3 different screens and 4 different components. And here are the amounts. This is me doing it with a TMR. Basically, you dry down the sample, and you can do it with a TMR, with a haylage, but with a corn silage, here are the recommendations. Simply put, when you're chopping it, you're looking at 1/2 inch to 3/4 inch chop length. Again, if you're setting yourself up for that, you're going to get pretty close, you'd like to think, to some of these levels. But in the upper sieve, if you want to get into detail, then 3 to 8% for corn silage, 45-65 in the middle, 20 to 30 in the lower, and then less than 10% in that bottom pan. You don't necessarily want too much of that to be ground up. So, and again, remember, this is all done on weight, so it's not necessarily what it looks like either. And dry, of course. Here's a recap of some of those parameters. Again, we covered NDF and starch. I hope that we're somewhere where we need understanding what those are right now. Just to recap, the lignin, that ADF factor, and the lignin, these are the undigestible parts of the feed. So we want these to be lower. NDF is the fiber, we want that to be lower too. NDFD, NDF digestibility, higher. Starch levels obviously higher. And then finally, something I haven't mentioned yet, but is milk per ton. Milk per ton is a little bit of a tricky one. It's good for ranking corn silages, and I'm sure you guys use it a lot in trials and whatnot, and you can probably speak to this. It's not to be used as we don't use it in ration balancing. It's not how there's too many variables of how that corn silage is going to feed out. What are you feeding it with? Who are you feeding it to, etc. But it is a good number. Again, your eye gets drawn to it. You had a 3,000 milk per ton now, and then or last year, and now you're 2,900. Well, now you realize that something has dropped, and what is that? So also worth mentioning that, and I don't really touch on it, but maybe we can talk about it at the end. One thing that I haven't touched on is that milk per ton and milk per acre are very different things. And so you should be keeping records and keeping track of what your dry matter or what your tonnage is per acre so that you can reference them back. I mean, the goal is to fully evaluate these crops. So we're getting high quality and high yields. It's not much use to have the best corn silage in the province and only have 6 months worth of it, right? Like you're really sacrificing a lot there, because then we're going to have to feed straw or purchase something else in. Yeah, I mean, we're talking in extremes, but this year we're under a lot of inventory management with corn silage. Reason for that is slightly different, but yeah, corn silage, keeping track of how much you're pulling off per acre and evaluating things that way too. And I'm sure, Adam, you talk to people certainly about yields and whatnot. So now I want to move on to what we can do to control all this. As a producer on farm, sampling pre-harvest. And this, everything that's happened up until this point, the plant's been growing, you're sitting in the field, you've got one shot at getting this right. And this is why field sampling and walking the fields is essential to determine optimum harvest time and to determine what we're going to get out of the cows over the course of a year. Traditionally, we go for that, we base things off the milk line, and I don't think I've walked a field with a producer where we haven't snapped a cob in half and had a look at where the kernel milk line is, and you're looking between 1/3 and 2/3 milk line. But what I would like you to focus a lot more on is the whole plant moisture. And how we do this is grab 5 to 10 samples from the field, run them through your wood chipper or even through the harvester if you've got it ready to go, dry that down, and you're looking for 63 to 68% moisture. The reasons that I believe that the focusing on this moisture has more of an effect. Yes, pay attention to the milk line, absolutely. But there are hybrid differences today that really can affect, like with these sort of stay green characteristics, and you guys would be more aware of this than I am, but the kernel might dry down and you get that milk line's progressed far enough, but the plant has stayed healthy and green, and we're not at the moisture of the whole plant. And now we're going to lead to storage issues or fermentation problems, butyric and whatnot. And that's particularly if it's a grain characteristic. And again, you probably can talk to more hybrids on that. And for a corn silage, you want these levels to sort of coincide with one another, but depending on what you've achieved. So again, worthwhile, and your nutritionist can do this for you, or the chipper days, but it's as simple as running it through the chopper, chopping it down. You have to do that. Mimic what you're going to be feeding out, because you can just dry it down quicker. You try and dry down something of a few inches, it's just not gonna work. Remember when you're doing this though, that typically these tests do underestimate your moisture by about 3%. So it is going to be wetter than what you think it is. So if you're getting something at 68% moisture, it might be above that 70 mark. So and I'm going to point to this later. I think with like targeting that 65%, that's your line in the sand when you go. I think that's going to prevent you from getting it too wet, and at the same time, you're not going to be over that 40% dry matter. So why is this so important? Let's first look at the starch levels. So I pulled up some data from Cumberland Valley, and this is last year's starch levels at different dry matters. So as the plant dries down, that milk line comes down and matures. Yes, the starch percentage level increases. Delayed harvest, looking to maximize on starch, might seem like a good idea. You can see from here, like at 25 to 30, we're at 23% starch. I don't think anyone wants a 23% starch corn silage. And then 45 to 50, we're at 36. Well, in doing so, we are sacrificing this fiber digestibility. Like other crops, as this plant matures and dries down and you see it, it starts to lignify, get woodier, and therefore this digestibility actually decreases. So your increased starch levels and your digestibility are inverse. So what you need to do, again, and it's useful because it's at a convenient dry matter for storage and whatnot, but looking at the milk per ton, which takes both these factors into consideration and otherwise, the averages for the last year of harvest at dry matter for milk per ton, your peaks here are at 35 to 40 dry matter. 30 to 35 isn't far off, but we drop dramatically when we are wetter and drop dramatically when you're drier across the province. So you're getting above 40 dry matter, you're really sacrificing on the corn silage quality as a whole. You may think that you've got that 45% starch, but you are sacrificing some serious fiber digestibility, and the cows just can't pull that energy and can't eat enough of that corn silage to make it worthwhile going that extra week or so. Another convenient thing is that 35 to 40% dry matter at this level is also the dry matter at which packing, fermentation, and storage are the most efficient. You get it too wet, ultimately you're looking at nutrient losses. When that silo runs and that water's coming out, you're losing a lot of goodies which you could have been feeding to the cows. You're also looking at butyric acid issues, which not only is palatability, but also the more acid we create in the rumen, we are fighting that all the time. More acid we create in the rumen, acid is the enemy of cows. Like butterfat will suffer, rumen function will suffer. We need to try and keep that pH stable and alkaline. If it's too dry, now we can't pack that bunk as tight. This leads to inadequate fermentation. We're going to get mold. You're also going to get higher dry matter losses, whether it's in the field, blowing out the back when you're driving from the field to the bunk, and at feed out. You know, those edges of those bunks, when that oxygen can get into those bunks, that stuff, again, we get mold, and ultimately, not only are you going to have to throw some of that away, the stuff that you don't, that mold, we then lead to a perfect scenario for toxin levels. So again, 35 to 40 dry matter, convenient because, you know, we looked at that milk per ton and we look at our storage levels, and this is where we need to be for that. So basically now, Adam, I think now we can just, and Greg, we can just basically talk about these benchmarks. And this is just basically a cheat sheet that I've put together. And I think that, yeah, it basically sums up everything we've talked about here and the reasons why. If there's anything on here that we, like I can just quickly touch upon everything, but I guess we'll hit them all in order. So dry matter in storage, you want 35 to 40% dry matter. That means at harvest, you're looking for a 35%. That would be what I would target, 35%. Once you've got that, 65 moisture. Once you've got that, it's go time. That way you're avoiding it being too wet. And if you get going in a decent amount of time, you're not going to be too dry. Trying to refine things a little bit here and there, you may miss your window. Starch levels, again, higher the better. In storage, we're looking at 30 to 45% is probably like reasonable levels. Obviously, I've seen higher and I've seen lower, but in general, the higher the better. On the subject of starch, process those kernels. No whole kernels in there. Monitor that. If you need to know where you are now, I mean, we've got plenty of time before corn silage comes off. Talk to your rep. Ask him. Say, how is my processing? You know, these are what is limiting me about my corn silage? These are discussions we need to have. Fiber levels, NDF. These are the two that I want you to look at. Easy to remember. The lower, when you come to fibers, if you just look at these two, NDF and uNDF, the lower the better. NDF 30 to 40%, average is 38.6 this year. uNDF, this is quite a bit of variant here, but 26 to 12. Again, lower the better. On the subject of fibers, I have included cutting height here too, but chop length, 1/2 inch to 3/4 of an inch, that's what you're looking for in the bunk. Cutting height is something I haven't really mentioned, but the higher that you cut, the less of those fibers you're going to get at the bottom of the stalk, and you're maximizing the percentage of that plant that is the cob.
So Dan, that's something I think is huge, and I've really encouraged my cooperators to do, is to cut higher. The bottom portion of the plant is essentially the ADF. It's that undigestible fiber. It essentially fills up the cow, doesn't contribute a lot to the diet. And at the end of the day, you may think you're giving up a lot of yield, but once you take the dry matter out of there, you're not losing a lot. And if you continue to increase your grain to stover ratio in your feed, it makes a lot of sense. So I like 18 inches as a benchmark. Don't be scraping the bottom. So.
No, and I think this is something that you really want to be talking about to both of your agronomist and the nutritionist, just to see where things are standing and how things are looking, both, you know, as the season progresses, and have this in your mind of what you're going to be doing. You know, calling me up as the harvest is running and saying, what height shall I chop the corn silage? Like, it's something we have to really calculate and look at, and not on a nutrient benefit, but ultimately to sort of maximize that quality. This is, again, something you want to sort of pay attention to. And through you guys, before that it even reaches the nutritionist, that's what we need to talk about. You know, how much are we planting? How much do we need to put in? Yeah, again, digestibility, these numbers, the higher the better. That 7-hour starch number, 70% or better, average of 73.2. NDFD 30, 55% or better. Toxins obviously as low as possible. And then just as an aside, your packing density, you know, again, we talked about that chop, we talked about processing the kernels and chop length. Packing that bunk, you know, getting that 16 pounds at least of dry matter of corn silage per cubic foot. And again, your nutritionist can do this. We have the tools available to see what your packing density is. Did I do a good job? I mean, now is a good time. We've got a nice face on the bunk. Drill it in, dry it out, drill it in and weigh it out. There is plenty of spreadsheets where you can work that out. Again, that'll reduce losses. Obviously it's too late now, but you will know for next year, you know, should we have spent more time? The last thing a nutritionist really wants to hear is, you wouldn't believe it, we got it all done in half the time we got it done last year. Well, that's might not be a good thing. These wagons are coming in, rolling in, and the packing tractor doesn't have time to sort of get things compacted down.
And I would always stress, if possible, put the second tractor on if there's an extra body around. That's a good. It's hard to slow down the harvester for obvious reasons, but putting a second tractor on the pit's probably the first go-to.
Yes. And then fermentation, like I pointed out with the starch digestibility, there are also other elements like the sugars and whatnot, but just allowing the corn silage to ferment for at least 1 month before feeding. So maybe managing your inventories and your storage systems to allow for you to feed, you know, to always feeding totally fermented corn silage, not only for starch digestibility, but also the rumen bugs that break down unfermented feed are different to the ones that break down fermented feed. And having to restart and start this process again for a cow, again, adds in more stress and more change. And cows do not like change.
Dan, one quick question, yes or no, are you a proponent of inoculants on corn silage?
Yes,
It's a whole nother subject, but.
Yes, it is. Yes, I would say so. Inoculants, they're not going to make a bad feed great, but they are going to help you along the way. It's a nice little safety net. It's the same when, I mean, on a typical year, I get asked about, you know, spraying fungicide. Is it worth it? Well, if you do the maths on a terrible year, it'll pay for itself for 2, right? So you kind of have to weigh everything up. But yes, I would say, again, if you, depending on what your goals are and what your desire, using an inoculant will help you. Like I say, it will improve a bad crop. It's not necessarily going to make a good crop great, but on the bottom end, it might help you out. If you're extremely strict and you can manage things and you're confident in what you're putting out there, maybe you don't need it. But certainly if there are some holes and you have noticed this, and you know, you have a few molds on there and the packing hasn't been up to snuff, the trouble you have, I know, is that everybody likes to back themselves, right? So offering that advice, yeah, well, of course I'll do it right. So, but again, these are those benchmarks and basically sums everything up. And I guess, do you have any more questions, Adam or Greg?
Yeah. No, that's great. I think we'll stop there and we'll move to the questions that have been coming in. So perhaps a few questions, Adam, that we want to clarify. I've got some questions coming in, but Adam, I think you have a few questions that you want to chat. We are joined now with Holly McGill from Wallenstein as well. I think Holly's role is to answer all the questions that none of the rest of us can answer. Well, particularly me, but so we're grateful to have you here with us as well, Holly. So Adam, why don't you take it away and clarify a few of the questions that may have come out of our discussion so far today.
So Dan, one of the things that you talked about first, or you hinted on, was toxins. Is there a specific time of the year, fall, or whenever you open up that bunk, that you want to be monitoring your toxin levels and you know, doing anything to manage that in the ration?
Yeah, so typically I will test everybody's corn silage right off at harvest for those toxin levels. But as with anything with feeding dairy cows, you need to sample the feed that's being fed to the cow at the time. Toxins, particularly in, you know, unpreferable storage situations, can grow and do change. And also toxins can be extremely variable, and it's difficult to sample it. So if there is an indication on that first test that we do have high levels, and even if we don't, it is worth resampling that again, certainly around Christmas time. And depending on the levels I get on that initial test, that'll determine how often I'm going to be sampling corn, like for toxins. So if I was to get elevated levels, particularly of VOM or DON at that initial sample, I probably would schedule sampling on that for 4 or 5 times over the course of the fall and the winter, just to keep an idea and give us a benchmark. If the level's lower and there's no indication, I would want to certainly double check that. But yeah, no, it is important to keep monitoring that.
Perfect. And for if there's any beef farmers or feedlot guys on the call here today, would these benchmarks you've indicated for dairy cattle or dairy rations, would they be suitable for what you'd be targeting in, you know, other ruminant livestock? Maybe Holly, you want to touch on that, or Dan?
Yeah, yeah, very much so. This is definitely applicable across species. You know, certainly as we get into some of the heavier feedlot diets, we're focused more on grain corn at that point. But when we're looking at, you know, if your beef cows are getting any corn silage, or if you're looking at sort of some of these like starter feedlot diets or sort of younger, lighter steers and cattle, these will apply across the board as well.
Perfect. And the other one that comes to mind is, you know, everybody has a different ration. Every barn has a different ration. Some are based on land constraints and how much haylage they may or may not have, or dry hay. So when you're looking at a diet that has, say a third corn silage versus a diet that has 2/3 corn silage in the ration, do your benchmarks change according to how much energy you're trying to drive or how much fiber digestibility you're trying to improve? Can you elaborate on that a little bit for us?
Yeah, Holly could probably talk at this a little more, but how I would address that would be, you still want a higher quality, but those sort of corn silage at a lower level, those fiber levels and those digestibilities have less of an impact on the ration as a whole. And now, maybe we are prioritizing the haylage, and thus those graphs I looked at, the corn silage's contribution, the NDF being a limiting factor, that is less of an impact. So maybe then what our goal is to maximize that starch intake to avoid feeding as much corn grain as we can. So Holly could probably give us a little bit more on.
No, I agree completely. You're right. I mean, I think when we look at some of the quality parameters related to starch digestibility or digestibility overall, those are always going to be important no matter what. Ultimately, no matter how much corn silage we're feeding, those numbers affect how the cow is going to be able to use it. But when it is included in smaller amounts, then certainly we are a bit more focused on the energy contribution. We're looking a bit more at the starch contribution, and we're going to be expecting that our fibers are going to be coming from elsewhere, from other sources. Yeah.
Is there,
My
we
audio
talked
still
about,
working? Yeah, go ahead.
Go ahead, Greg.
I was just checking my audio. Can you hear me okay?
Yep.
And so I wanted to interject on the milk per ton discussion. We use that, and as I'm sitting here thinking about it today, we're taking, I'm assuming, starch and fiber digestibility that go into that equation, and the starch may or not be the right starch number that we're punching into that at harvest time. Is milk per ton a good way to sort out that fiber digestibility versus starch relationship? I'm just a little leery about it.
It's a calculation that's broken down. I mean, from the nutritional point, it's not something that I delve too deep into because we don't use it for ration balancing. It's like I mentioned in the presentation that it's an indicator of a quality and a good rank, like for you guys might be useful. In terms of the calculation itself, I'm not sure, Holly, how much how that is broken down and what the weighting is on those levels, but
for actual weighting, I will admit I'm not positive, but it does take into account like your starch, your NDF, your average NDF digestibility. So it does take into account a lot of the parameters that we did talk about.
But yeah, so I guess one of the key weaknesses would be if your starch number is low, but it's going to get a lot better, to throw a silage under the bus because it had a slightly lower starch number, maybe a bit of an overshoot on using the milk per ton, right?
Oh, absolutely. And certainly, like I mentioned, if you're sampling it in different storage scenarios, that digestibility has a huge impact versus the starch. I mean, a starch at 40% of a starch level, if the digestibility is at the 70+% and the digestibility is at a 40%, you're getting significantly less use out of that starch level. So that definitely needs to be taken into consideration.
Very good.
So another question that comes to mind is, a number of my producers may be limited just from bunk space, or they feed out of a top unloading silo. Are there any Coles notes or cheat sheets that you could offer on ways to improve the fermentation rate or feeding green silage in the fall if you have no way to have fermented feed on hand? Is there anything that comes to mind that you've seen work better or not?
Well, with the green feeds, the first thing I would say is sample it regularly as the crop is developing, because it is changing. For us, we obviously using yeast to help with help those rumen bugs adapt. The challenge obviously is that the rumen bugs that process unfermented feed are different to the ones that process fermented feed. And managing that as it develops, it's not a question of, sample it at chop time and then sample it again once we get to Christmas and everything's settled down. You have to keep monitoring that as it goes forward. And honestly, for me, working with Holly, like, we go through the process and what the cows are telling us, as opposed to maybe what the nutrient analysis is giving us. If we look at, manure, look at milk production components, if the cows are indicating that they need, more energy, more fibers, whatever it may be, then we need to react to that as opposed to the analysis at that point.
I have a question coming in from Daryl about are all shaker box charts the same? Like there's the Penn State shaker box. Is there differences amongst shaker box charts?
So there is a little confusion, because Penn State actually have, and now it's a 4-box one. I don't know if you remember the photo. It's a 4-box with 3 screens. Traditionally, and I do still see some people using them, there are the ones that just have the 3 boxes, therefore the 2 screens. So you have to be careful that you're using the right sort of, first of all, Penn State shaker box, but there are various different screens that you don't want to get confused, that they use for grains and forage particles. But those recommendations are different for a corn silage, a haylage, and a TMR. So it is worth ensuring you're using the right one. For me, I solely use a Penn State shaker box, the 4 boxes and the 3 screens. So that for me is uniform. I think as advisors, if you're working with clients, it's simpler just to stick with the one system, and then you sort of get familiar with those numbers and those targets, right?
Good. Another question from Jerry out west. Comment on the 240-hour digestibility versus the 30-hour digestibility. What's the purpose? What's your feelings about having meaning behind those two numbers?
So Holly, again, probably a better answer this than me. My take on it, and again, it's not something I directly look towards that 240 number, but it gives an indication that corn silage is still working even at that point. I mean, obviously a cow's not consuming that or digesting those forages for 240 hours, but it gives an idea that, the corn silage is still working within the rumen, and there is still more to sort of give, as opposed to the process is over. If you think of it like a graph, then it gives you an indication of sort of that rate over a longer term. But Holly could probably talk about the science of that.
Yeah, it's essentially why we have the both of them is as Dan said, certainly we're not expecting that feed is going to be hanging around in a rumen for 10 days. I mean, we hope it isn't going to be, but the 240 value gives us an idea of and helps us calculate that uNDF value. So when we went back to when Dan was talking about the NDFD versus the uNDF, that 240 value gives us an idea of what the undigestible NDF is going to be. So if we still have a value at 240 hours of fermentation, then we know that it's absolutely not going to be broken down any further than that. That's the most digestible it's going to be. Kind of gives us an idea of that end point.
Excellent. Question, a little bit of a follow-up. Maybe this is more of a question for Adam, but Jerry wants to comment about flinty versus dent hybrids in this discussion of silage quality.
Yeah, so when you look at dent versus flint, you're looking at the nature of the kernel. Flint corns tend to be much harder and much, I'm trying to write the term, but vitrosity is I think part of the description. So regardless, you get a lot more of very hard starch in the flint type kernels. Those kernels in our lineup, and then you look at corn and in general, tend to be on the more early maturities just based on the background genetics. And that flinty corn is certainly much harder to not only to process, but to be degradable in the rumens. So you tend to get more of that hard starch to pass through. Where in the dent corns, you get more of that floury white starch, which tends to be a lot softer. Probably breaks down a lot easier, more surface area in the ration for those microbes to actually digest. I think you would be able to pick out the starch availability between a flint hybrid versus a dent. And if, depending on your area or the hybrids that you're using, if you are getting to a more of a flint type hybrid, you might really either need to look at always feeding fermented feed or doing a super job on your processing to get those kernels really broke down as best you can. Hopefully that answered what you're looking for there, Jerry.
Good. So this is a question perhaps for all three of you, but I don't know whether the nutritionist side of it have looked at this specifically, and that is fungicide applications at tassel time. We generally have a feel that they're improving yield, but Andrew's question is, do they lead to better stay green and to better digestibility? Again, I'm not sure where Holly or Dan you go on assessing whether a silage has been sprayed with a fungicide, but I know Adam would have some comments, so I'll throw it out to all three of you.
I'll start to let you guys think about it a bit. I think I'm pretty sold on the idea that if you're in the right environment to spray a fungicide, I'm a huge proponent for it. It does provide you that stay green effect, in my opinion. And using the right fungicide can also give the opportunity to reduce your toxin load. But essentially, when I look at good quality silage, if I can keep that plant alive and healthy, the fibers maintain their digestibility while you allow the ear to mature, which then provides you more starch. So it's kind of the best of what Dan was talking about, where you maintain your fiber digestibility and you improve your starch number from that application. It also harvests widens your harvest window. So if you get a weather event or you have a lot of acres to cover, it gives you some benefits to get those acres covered over a wider period of time before you drop off on maturity. Yeah, I think there's a number of benefits, and I would say then we look at our trials, you tend to see a nice increase on milk per ton on top of your tonnage. So it's, in my mind, the calculations I've done has been a pretty good return on investment to put a VT fungicide on. Just my caveat would be make sure you're putting the right chemistry on to get the bang for your buck.
So cool. Any thoughts, Dan, Holly?
No, I agree. I've not looked at it into that depth, but I would say, anecdotally, or just look at it broad strokes, you're keeping that plant healthy, it stays alive for longer. Again, greener plant, high digestibility, longer harvest window, everything Adam said. Yeah, I also am a proponent for your fungicide. So
Yeah.
Cool. Hey, a question from Wayne. Give me an idea of what the yield per acre loss is going to be if he moves from a 6-inch cut height to an 18-inch cut height. That's a bit of a mathematical question, but I'll throw it out to you. Anyone got a feel for what a guy's going to give up in tonnage going from a sort of scraping her down at 6 inches versus moving it up to 18? So a foot of stock not coming in.
So the numbers that I ran, and they're not necessarily hard numbers, more theoretical, but say you give up half a ton per acre, and say you're going to cut 40 acres to fill up your silo or your bunk. So 1,000 tons over 40 acres is only 20 tons. So at the end of the day, if you're going to cut 40 acres of corn silage, you're going to get 1,000 tons if you cut it 6 inches of height. But if you cut 41 acres of corn silage at 18 inches, you're going to get the same volume, but I believe you're going to have a significantly better feed sample in your bunk. And again, that what you're leaving in the field is not going to contribute a lot to your diet. So the extra acre out of 40 acres, in my opinion, is either another basically an hour's worth of cutting if you're using the pull type harvester, or a matter of minutes for a self-propelled. It's a pretty easy decision in my mind to leave that headage around 18 inches.
Coco,
Yeah.
any follow-up on that? We good with that answer?
I think so. I think my always thought was for every 4 inches is around 1 ton of corn silage would make sense. But again, that yield, that digestibility improves dramatically. What were the numbers he was thinking of? Sorry.
Just a foot in higher cut height, 1 foot higher.
So that at a foot, you might be looking at 5% better fiber digestibility numbers at a foot.
Yeah, fair enough. And we're happy to sell you a little more seed if you need to grow a little more, so you can raise the cutter bar just a little more, right? Hey, here's a question on.
Can I just cut you for a second, Greg? If you said 5% on that fiber, and you were talking that 1 point could get you an extra third of a pound of milk per day, I think was a number that I've heard. You know, that's almost 2 pounds of milk per day per cow, or whatever pounds per steer per day. The numbers add up pretty quick on leaving some of that stover in the field.
Yeah, very good. So here's the question. We didn't really bring up TDN too much today. So the question from Danielle out in Alberta, how does TDN relate to milk per ton or digestibility? Comments on what TDN means to us.
Holly, I can let you take this,
Yeah.
TDN.
So TDN stands for, total digestible nutrients. It works up, I'd have to pull up my notes to recall kind of everything that it takes into account. So it relates to milk per ton in that it uses a lot of the same parameters for calculating TDN as milk per ton does. So, it'll take a lot of the same things into account. Again, it's important not to really hang your hat on any, as we talked about with milk per ton, we don't want to necessarily hang our hats on any one specific factor or, nutrient factor in a sample, but that's sort of how it relates there. I will say we don't use it a ton in dairy rations. I probably focus on TDN more on the beef side. That's still something that comes into play a little bit more in some of the beef rations that I run. But certainly, as I said, if we're looking at how it compares to sort of a milk per ton and digestibility, it definitely takes those factors into account as well.
Excellent. So just a little bit off topic, but interested in your comments. A question coming in about growers that are using sort of overwintering forages. So essentially seeding a cereal rye in September and taking it as a feed, sort of end of May. What's going on in terms of dairy herds and utilizing these overwinter forages? Any thoughts or comments from any of you on where that's fitting into a dairy herd management or ration management?
So this isn't going to be very satisfying, but those winter crops, the variability on those is pretty high. So I have customers that is their number one grass forage, and everything works, as you would expect, and hitting extremely high numbers. Everything is balanced in the ration to no detriment to using, say a rich alfalfa, providing you have enough there. And obviously we have to supplement with some extra protein, but they do need aggressively management, and chopping and harvesting of those forages. The window is very key in terms of that variability. So
miss the cutting window on a cereal rye. 2 days in May, and you've gone from a nice quality forage to something that you're not sure what to feed to.
Yes, and so you have to be very strict.
Sorry, Adam?
That's what the beef cows eat.
Yeah.
There you go. Good. Well, hey, that sort of wraps up our questions that have come in. This has been a really informative time. I know not enough about science, and I feel slightly more educated today, just personally speaking. So that's been excellent. Our appreciation to Dan and to Holly for being with us today from Wallenstein. Great to have you with us, and the expertise that you brought with us. I'm sure we're going to get more questions than we've got answers for coming in after this session. But we thank you for being with us today. We thank you for those of for all of those who have joined us for this webinar. I will remind you that a recording of this session will be available at our website at Maizex.com. Also, all of the other sessions that we've done in this series. So this was number 9. All of those sessions, if you missed any of them over the past 9 weeks, you can go to Maizex.com and watch the recorded versions there. So pick up on maybe some stuff that you might have missed or get some clarification. So with that, again, thank you, Adam. Great to have you with us today as well. Thanks, everybody, and have a good day.
Bye-bye.
Thanks, everyone.
Thank you.